This is Accelerated Geometry, section 10.1, the Pythagorean Theorem and its converse. So here is an attempt at humor. So we have some guys back in the days of the Roman and Greek time, and it says, "You may be right, Pythagoras, but everyone's going to laugh if you call it a hypotenuse." I don't know if that's funny or not, but it looks kind of cute. Okay, the theorem of Pythagoras. In order to do this, we have to know some terms. So here is a right triangle. This Pythagorean theorem only happens in a right triangle, so I need a right angle. The two sides that make up that right angle we'll call A and B. Those are called legs. The side across from the right angle, this is like an arrow head pointing over here, it points to the hypotenuse, which we're going to call C. We would have done a computer lab if we were in school, and this is what we would have discovered here. The area of this first one is 2.457 square centimeters. The area of this one is 6.324, and the area of this one is 8.781. Okay, here is a right angle. These would be the legs, A and B, and this would be the hypotenuse, C. So to get this area here, that would have been A times A, or A squared. If this side is B and this is a square, this would be B, so this comes from B squared. And if this side is C and this is a square, then this side would be C, so this area would have come from C squared. So the two smaller squares area add up to be the area of the larger one. So what this is saying is A squared plus B squared equals C squared. Also in a lab, you would have created this picture, and then you would have moved those colored pieces into the bigger square. And again, you would have been showing yourself that this is side A and side A, so this would be A squared. This would be side B and side B, so this would be B squared. And this would be side C and side C, so this would be C squared. So this A squared stuff and this B squared stuff added together fit into the box that is C squared. So this brings us to conjecture number 88 on our list, the Pythagorean Theorem. So in words, in a right triangle, the sum of the squares of the lengths of the legs equals the square of the length of the hypotenuse. Or, if A and B are legs and C is the hypotenuse of a right triangle, then A squared plus B squared equals C squared. So this is actually the one that is listed on the conjecture list. Okay, now I took a triangle and I made this be an obtuse angle. So here, this is 140 degrees. And I made the longest side BC. And then I thought, what happens to A squared plus B squared and in terms of C squared when I have an obtuse angle in there, not a right angle? So look what happens. The A squared plus B squared here is less than C squared. Here A squared plus B squared is less than C squared, and in all the rows that I have here, A squared plus B squared is less than C squared. So this leads us to a conjecture that is not numbered, but it comes after C88 on our list, and it says, in an obtuse triangle, where C is the longest side, A squared plus B squared is less than C squared. So if I looked at a right triangle, and now I looked at an obtuse triangle, I wonder what happens if we have an acute triangle. So this time, this angle here is 86 degrees. And again, I named the longest side C and the other two sides A and B. And I did some measuring and set this up, and look what happens. Here's my A squared plus B squared column. Here's my C squared column. My A squared plus B squared is always greater than the C squared. So this comes to another conjecture which follows the last one you put on the list. In an acute triangle where C is the longest side, A squared plus B squared is greater than C squared. Okay, here is our first example. How high up the wall will a 20-foot ladder touch if the foot of the ladder is 5 feet from the wall? So this is the foot of the ladder, the bottom of the ladder. It is 5 feet from this wall that is perpendicular to the ground, so I have a right angle in there. So I have a right triangle with this side, the length of the ladder 20, this side 5, and I want to know the height. So I said I can use A squared plus B squared equals C squared in this right triangle. The hypotenuse across from the right angle is 20. So that's my C, and it doesn't matter where I put the 5. I could put it in as A or as B. 25 plus H squared is 400. Subtract 25 from both sides, and take the square root of each side in order to get H alone. And I get the square root of 375, or 19.4. So the ladder will touch the wall about 19.4 feet up from the ground. Find the area of this rectangular rug if the width is 12. So that's over here. So I could also put 12 here. And the diagonal measures 20. So here they have the diagonal is 20. So the rug is at a 90-degree angle here in the corner, and so therefore across from it would be the hypotenuse of 20, and then L and 12 would be the legs. So I can use the Pythagorean Theorem. A squared plus B squared is equal to C squared. 12 squared plus L squared is 20 squared. 12 squared is 144. 20 squared is 400. Subtract 144 from both sides, and now take the square root of both sides. So L turns out to be a perfect 16. Now the question was, find the area of this rug. So the area of a rectangle is base times height. So the base and the height would be 12 and L, which is 16. So if I multiply those, I get 192 square feet. If I were to create triangles with the lengths given here, these would all become right triangles. So these are called Pythagorean triples. If you know these, sometimes it'll save you some time, because let's say that they tell you in a problem, in a right triangle, one side is 3 and the other is 4. Instead of writing 3 squared plus 4 squared equals C squared and going through the whole arithmetic and algebra to solve that, all you could say is, oh, if two sides are 3 and 4, and this is a right triangle, the hypotenuse has to be 5. So these are helpful for homework, saving you a little bit of time, and also for ACT tests where time is very important. Okay, here's another one, 5, 12, 13. So if I have a side that's 5 and another side that's 12, the hypotenuse will automatically be 13, creating this right triangle. Here's another one, 7, 24, 25, 8, 15, and 17. Now, how did they get the rest of these underneath them? They took this one and multiplied everything by 2. They took the top and multiplied everything by 3. They took the top and multiplied everything by 4. So sometimes this could be the situation too. They could tell me, in this case here, that this side is 12 and this is 16. And then I think, oh look, 12 is 3 times 4, 16 is 4 times 4. They're both being multiplied by 4, and 3, 4, 5 is a Pythagorean triple. And since these were multiplied by 4, I multiply this by 4, and that would get me a side of 20. Now, here's conjecture number 89. If the lengths of 3 sides of a triangle satisfy the Pythagorean theorem, then the triangle is a right triangle. So if I look at conjecture number 89 on my conjecture list, it says, if a triangle has sides A, B, and C is the longest side, and a squared plus b squared equals c squared, then the triangle is a right triangle. So that's how I printed it up on your conjecture list. A steel pole 150 centimeters in length, so here's the pole, 150 centimeters in length, has been placed in the ground ready for cement to seal it in place. To check to see if it is perpendicular to the ground, the contractor has measured a distance 180 centimeters from the top of the pole to 180 centimeters from the base of the pole on the ground. Is the pole perpendicular to the ground? Well, 180 is the longest side, so that would be C, and the other two sides would be A and B, and now let's check it out. I'll have A be 80, B be 150, and C be 180. When you plug this into the Pythagorean theorem, this is what you get. A squared plus B squared is 28,900. C squared is 32,400. They are not equal to each other, so therefore it is not a right triangle. So they're going to have to do some adjusting before they pour the cement. Okay, those are some examples of the Pythagorean theorem in use, and now I think you're ready to start the homework.